So the whole chapter is about descriptive statistics. In 7.1, we mainly looked at charts and graphs as describing data. And hopefully those charts and graphs you made worked well, or went well. In 7.2, we're actually going to make some calculations and find what are called summary statistics. And the ones we're going to explore this week are the count for the data set. We usually call that N. The sample size. And some other basic ones are, is there a minimum value, maximum? Based on the minimum and maximum, we can calculate a range. We did that when we were playing with histograms. And then we're going to move on today to take a look at what's called the mean, average, median, is a middle number similar to average but different. And we'll look at how they're alike and different. Take a look at percentiles. And then there's some special kinds of percentiles called quartiles we'll look at. And we're going to look at an idea called standard deviation. And the goal is to get used to calculating these, pretty straightforward on a spreadsheet, what they mean and how we can use them to describe and summarize some data and combine them with graphs. And so the application for the end of the week is to take these summary statistics combined with some charts to be able to tell somebody about a data set so they don't have to look at the raw numbers. So let's take a look at some data. I'm going to pick up with that data collection we started with last week, and I'll reshare that with you all. So this is the same spreadsheet from last class. Put this in the chat. Or alternatively, if you go to your Google Drive and look at your recents page, then it should be in there under recent in your Drive. See it there, or you didn't get to it last week, it's in the docs. Now, I've added to it just a little bit because a few more people have taken the survey since then. So we have a few more values in the data set to play with. When I do a survey, I mentioned before, with Google, Google will send the results to a spreadsheet, and I don't want to mess with that tab. So I usually make a copy of it. If new data comes in, then I have to recopy it to get it into this one right here to play with. So I recopied some of the data, so there's now 140 entries into this data set. And today we're going to play around with several of the quantitative ones. And so why don't we start with height in inches? And so I'm going to take that column, put it in a new tab to play with. And we played with this last time when we made a histogram. I'm just going to take it a little farther. So I'm going to start over. This one more height. So if you do open this up in Google Sheets to play along, if you want to repeat what I'm doing here, you would have to make a copy of it to play with. Otherwise, this one's read-only. You don't have access to edit it. So if you want to edit this too and try to replicate what I'm doing again, you would have to make a copy of it. So it's up to you whether you want to just kind of follow along or give it a shot yourself. And we'll do this for a couple of different data sets to try and get used to it. Often it's nice to take the data and sort it instead of the order that it came in, but sometimes it's in different orders for various reasons. So we could, for this data set right here, we could sort everything by age And we would want this 48-year-old to have that same height of 68 inches, or this 31-year-old, we want to make sure their height of 69 stayed with them. So just a reminder about sorting in a spreadsheet. If I wanted to sort all of this data here in different ways, I would highlight the whole thing. Easy way to do that is from the upper left, Control-Shift down arrow will take me to the bottom list of the list, and then Control-Shift right arrow will look for the right edge of the data. So from the upper left, if I do Control-Shift down and then Control-Shift right arrow, that should highlight everything. I'm just going to scroll back up to the beginning. And then if I wanted to sort it by height here and keep the relevant information in each row, because each row is a person, I don't want to mess that up. The correct way to do that in either Google Sheets or Excel would be to use sort range. Not these first ones right here, sort sheets, sort range by column A, but I want to be able to choose how to sort it. We always want to say, yeah, there's a header row, so that way we can choose how to sort. So here I could sort by height in inches. And when I do that, it's going to, again, put the smallest at the top, largest at the bottom, but all the information in one row stays in the right row when I do that. Now, when we do those sorts, there's lots of things we can do. There's going to be people that have the same height. So I might want to do something like first sort them by height, and then for people that have the same height, I might want to sort them by, say, age. So all the people who are, say, 68 inches tall will then be also sorted as age under that. So you can have multiple sort criteria when you do something like this. Just kind of a side note, I'm playing with a spreadsheet. All right, so that's kind of besides the point. Let's get back to this. What we want to do is just put some summary statistics here. So again, first thing I want to do, I can click the A at the top to highlight the whole column. And then I can sort this range. It has our header row. I want to keep the header at the top. That's the reason we select that. And I think I'm going to go, yeah, smallest to largest. I can see that there's 4 numbers that were misproperly entered. And so I don't really want to use those in my summary statistics because I believe they're errors. But it could be there's a reason to keep those numbers in. I don't think we should. So I'm going to delete those and then shift those cells up. And start making my summary statistics. So first, I'm just going to make a bunch of calculations, and then we'll talk about what each one means. So we always want to know what the count is for the data set. That's that variable we call n, sample size. And that one's pretty straightforward. There's a command called count, which looks at a list, and in this case, calculates all the numerical values. So if I use count on column A, it's going to ignore height in inches and any other words it sees and only count the numbers in that column. And it counts 135. Don't want to fill that down. So we definitely want the count. Along with the count, I usually get the minimum. I'm just going to call that min, and the maximum. And then based on the min and the max, I can calculate the range. So the minimum is just the command min. And I can just set it on column A because all that is in column A is the height. If you have other stuff in that column, selecting the column header, the A at the top, is not a good idea. You would want to just select the numbers. So you always want to use that with caution. Can you select the whole column or not? In this case, it actually is okay. And then max, similar, is just max. And then we can do it on the whole column. And something there, parentheses. Column, parentheses. And the range is always the distance between the max and the min. So for range, that's a custom one. I just type equals and then click on the value of the max minus the value of the min. So that's kind of the start of our summary statistics. I'm going to put a space in between those two. So those are the first few easy ones to calculate. Next thing I'm going to do is the mean. Then standard deviation. wider for that. So mean, remember, is average. And there's a bunch of different kinds of averages. We just want the straight average. It's called the arithmetic mean. And again, clicking on the column heading in a spreadsheet is okay. The mean adds them all up and divides by how many. So just to double check that, if I were to do a sum on those numbers in column A, right, add up all those heights and then divide that sum by the count, how many numbers are in the list, that's how mean is calculated. But we have a quick version of it that's just called average. Standard deviation, so if we start typing equals ST for standard, there's a whole bunch of different standard deviation formulas. We want the one called STDEVS, which is the standard deviation for a sample. So that's super important, standard deviation for a sample. And then I want the whole column of numbers for that. So we're just gonna get that calculation in there. We'll talk about what it means in just a little bit. All right, moving on for a few other ones. This next group are a start at percentiles. And the percentiles that we're going to calculate are called quartile 1, quartile 3. And there's several ways to calculate each of these in a spreadsheet. The usual way for quartiles would just be to use the quartile command. Now on Excel, if you're an Excel user sometimes, the quartile command is the same as the quartile inclusive. I'm just going to choose the quartile one, but it's the same as quartile inclusive. And quartile needs two things. It needs what's your data, and a quartile is a mark that we make that separates the 4 quarters. So this is the first cut we make in the data that says 1 quarter is below. So we want to say we want comma the first quartile. The median is the number in the middle. So it's the second quartile. But for now, I'm going to use the median command. I'll show you some of the other versions of the formulas in a sec. The median just needs the data. And then quartile 3 would be that cut we make so that 3 quarters of the data are below this point. So equals quartile data, comma, which quartile do we want? We want the third one. And these right here are the major summary statistics. There's a few others that are based on these we'll get to in a little bit. Quartiles I mentioned are percentiles, and a percentile is, again, it's a mark we make in the data where a certain percent is below that point. So I'm just going to calculate quartile 1 a slightly different way. I'm going to use the percentile, and there's a percentile inclusive, exclusive, and percentile rank. So percentile rank is kind of a backwards calculation. We're not going to worry about that in this class, but percentile or percentile inclusive are the one we want here. And percentile, like the quartile, wants to know where's the data and then which percentile we want as a decimal. So I'm looking for quartile 1, which would be 25% at or below. So I would enter 0.25. So that notice gives me the same exact number, just a different version of the formula. So I'm going to do that again for quartile 3. It is a percentile. So I can use the percentile command here. And it wants the data, and which percentile do we want? So the third quartile would be 75%, so 0.75. Now the median is in the middle when the numbers are in order, right? I use the median command here. I could also get that by using the percentile command. So percentile data, comma, if it's in the middle, that means 50% or 0.5 should be below that point. Give me the same number as the median. It's also quartile 2. So the median has multiple names. So double check that. Quartile data, and this would be the second quarter. 2/4 is a half, so I put a 2 there for a quartile. And we'll reuse these a bunch of times to get used to them. So just a note on the median here, the median is also P50, 50th percentile, or Q2, second quartile. So again, these are the major summary statistics here. Just gonna highlight those, make it a little prettier. When we calculate these, notice sometimes I get a whole bunch of decimals. The standard rule is to look at the data and go one more decimal point than the data. So somebody entered theirs with a decimal, 1/10, another 10th, another 10th. So then I would round to the nearest hundredth. So for the mean and standard deviation, I'm going to decrease the number of decimals to 2 places. So when we do summary statistics, we always go, if necessary, one more decimal point than the data has. So if the data was whole numbers, we would round to the nearest 10th. This data is to the nearest 10th and a couple of points, so we're going to go to the nearest hundredth. All right, so summary statistics. So next thing I want to do is I want to take a look at some of these summary statistics along with a histogram. So we're going to make a histogram. Remember, there's a couple ways to make a histogram. We're going to go with the easy way. The easy way is to select the data, and I can select column A since that's the only thing there, and then just ask Google for a chart. And most of the time when you select a raw set of numbers like that, it's going to make a histogram. So here's a possible histogram. It's going to use some special rules it has to determine what the categories are. So the first one goes from 50 to 52.73, 52.73 to 55.45, and so on. So that's kind of messy there. Usually I like to pick nicer numbers. And we looked at some techniques for how to choose nicer numbers before. I'm just going to wing it here. So to change the numbers it chooses for how to group the data in the histogram, we go to the histogram section. And then instead of having it automatically choose the bucket size, and the buckets for each of these columns, like 66.36 to 69.09, we can choose our own width for the buckets. So let's see, they picked a width of almost 3, right? 50 to 52.73. So I could try, instead of auto typing a 3, enter, get slightly nicer numbers, right? 50, 53, 56, 59. That's not bad. We usually aim for 6 to 20 columns or buckets. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty nice. I think this one's okay. And again, we can just play around by picking different buckets. So I could have the bucket width be 2. And it goes 50 to 52. That's not too bad either. Let's see, what do I want to do today? The mean is 66.45, almost 66 and a half, which lives in here. And the standard deviation is almost 4. What does a bucket of 4 look like? So remember, there is no best histogram. There's just different choices. And hang on, I want to see who just ding dong in. Amy, welcome. We got almost the whole crew here.
Hi.
So I'm recording this so you can check it out later. And I'm kind of answering the question you asked me about earlier, which was how do you decide on how to make a second histogram?
Awesome. Thank you.
I'll repeat a little of this again right now. So I'm playing with height in inches. And you're going to want a copy of the spreadsheet we're working on. So let me share this in the chat again. One downside of the chat in Zoom is once you join a session, you don't see any chat that happened before you got there. So for the rest of you, I'm putting that link in again so Amy can get to it. And if you want to play independently on your own, then you would need to make a copy of this. So once you open it, you could go to File, make a copy, and then you can pick up editing where I am here on your own version, or you could just watch. It's up to you. All right, so I'm playing with this histogram here, and I think I'll just start over. Fun. So quick histograms. Google's really good at them. Highlight your data. and then insert chart. If Google sees just a list of numbers, it'll often say, hey, let's make a histogram. If it doesn't, then you search for the histogram option. And a histogram is a special kind of bar chart. And when you point to it, it'll tell you which one it is. So I want the histogram, which it picked anyway. It picks some weird groupings down here based on its magic math in the background. I'm just going to clean that up a little bit. So 50 to 52.73 is almost 3. So one way to clean this up would be to go to the Customize Histogram and change from automatically make groups to make groups that are 3 wide. So it's going from 50 to 53, 53 to 56. And the lower number is always in the column to the right. So if anyone has a height of 62, they're in this column right here. If anyone has a height of 65, they're in this tall column right here, and so on. So the lower number in the quick histogram maker is always in the next column. The upper number is in the next column, so on. All right, so let's see, back to histogram. And then I had just picked 3 because it was close to what Google picked for the bucket size. But then looking at the standard deviation, I was thinking maybe 4. So standard deviation is a measure of spread. I'll explain in a little bit. So I think I'm going to go with 2 maybe. What's that look like? Yeah. And then here, 50 to 52, there's no one in there. So if I wanted to start the histogram at a different place, that is down on horizontal axis. And so I could choose to start at 52 instead by just typing that as the min, and it redraws it. I could start at 51, and if I'm jumping by 2, then it'll give me odd numbers down there. So every histogram shows a slightly different picture of the data. Sometimes they're indistinguishable, like this one right here starting at 51 looks pretty close to the same as the one that started at 52, right? The where each number falls shifts a little bit, but it's basically the same shaped graph. Is there a best histogram? The answer is no. There's just many decisions you can make when you build a histogram. And the big ones are, where do you start and how wide your groups are? Or how many groups do you want? And I talked about that in the last class. So I think that looks okay. So I'm going to start at 52 and jump by 2 with this bucket size. So that's my histogram. It needs better titles. So I'm just going to change this a little bit. Heights of students. Height in inches, that's good. I need a label for this over here. And here we're just counting how many students fall into each group here. So that is the vertical axis. So best title I could come up with there would be something like number of students. This is known as a frequency histogram. So often people will type something like frequency. But then when someone looks at the graph, they might wonder, well, frequency of what? So we might as well be more specific, the frequency of students. And frequency means count, so we're finding the number of students. So usually with these graphs, I try to come up with a plain title that's descriptive enough. So rather than the technical name frequency, number of students is a much better name for most people to look at here. Okay, so here's my graph right there. And what I want to do is just draw on it a little bit. So let me get a screenshot of this to scribble on. And I also want to play with the summary statistics and talk about what each means. Let's turn off that yellow, that's kind of ugly. Giving me a headache. Sorry, I'm fighting with the Zoom menu also at the same time here. So let's copy all of that. Boom. Got it. All right. So these are all the summary statistics that are discussed in the textbook. So hopefully you started reading section 7.2, which is what we're covering here. And I'm going to start off with measures of center. And measures of center mainly are the mean and the median. So let's see where the mean and the median go here. So the mean is 66.45, or about 66.5. So that's 66, 67's in the middle. So 66.5 is like a quarter of the way over. So right here is the mean, and the mean is given the symbol X with a bar over it. So there's my mean. The median, let's use a different color for that, how about blue? 67, so it's just a little tiny bit bigger than that. They're pretty close to next to each other, but it's right here. So I'm going to put an M as the letter we usually use for the median. And it's a lowercase m. And notice that the mean is just a tiny bit less than the median, so that often happens. If I were trying to describe the shape of this graph to somebody, that's called the distribution of the data, the shape of the graph. Shape of histogram, to be more specific. It has kind of a bell shape. So if I kind of drew a line through what's going on here, it's kind of got this bell type shape to it there. And it's almost symmetric. The left side goes a little farther than the right, but not too much. So I might say for this distribution, this is relatively symmetric. But it's got a slight more of a tail on the left than the right. And so whenever you notice a tail to the data, one side sticks out more than the other, that's called a skew. So there's a slight, sorry, left side, slight left tail. And so a slight left tail is usually said to be skewed left. And it turns out, and we'll explore this with some other data sets, if it really is skewed left, if there's a pretty obvious tail on the left side, what you'll find is that the mean will be a little less than the median. So this left skew gives us a mean that's smaller than the median. So we'll look at some other data sets to see that that happens often. And it's because these smaller numbers are pulling that mean to the right. Because when we calculate the mean, remember the mean is the sum of the data divided by the count. So the sum over the count. The median is just in the middle. The median doesn't care what the min or the max is. It's just in the middle. If somebody reported back that they really weren't 52 inches tall, they were 50 inches tall, so there was a number over here more maybe, that would pull that mean further to the left. But the median, it doesn't care whether the smallest number is 50 or 52 or 5, it's gonna be right here in the middle. So the mean is subject to being pushed around by numbers on the edge, the min and the max, for example. The median is not, it doesn't care. So just an observation about that relationship there. Let's see, let's talk about standard deviation and how that relates to this graph. So the standard deviation is about 4, and standard deviation is related to the mean. So standard deviation is an average distance from the mean. And so the mean is just the average of all the numbers. The standard deviation is, on average, how far is each of these other numbers from that mean right there. So I'll show you how it's calculated besides using the formula, and we'll never do this again, by the way, but I need to explain a little bit about where the standard deviation comes from. And we'll just use a few numbers. So we have some heights of people. And if we look at just some of those 135 heights, there was somebody that was, say, 56 inches tall, and there was somebody that was, say, 62 inches tall, and somebody else was 66 inches tall, and 68 inches tall, and 78 inches tall, or 78 is a little bit too tall. So it was 72 inches tall. There's all these different heights. Now, there's also this average height. So let's, for fun, make the average a little easier. Let's let the average here just be 66. It was pretty close to that. So if of this group of people, right, the average was about 66, 66.45, so the nearest whole number, we'll call it 66. So I'm 68 inches tall. So that means I'm above average, right? This height right here is above average. This height of 66 here is just average, if we're calling the average 66. 62, on the other hand, is a little bit below average. So every number in the list is either average, below average, or above average. Now we can calculate how much something is above or below average. That's called deviation. Right? So I deviate from the average. My deviation is 2 because I'm 2 inches higher than the average. So deviation is whatever number you are, we call that x, a number in the data set, minus the mean. So for me right here, 68 inches, if I take my x, my height, 68, and I subtract that 66, the average, I get 2. So I have a deviation of 2. The person that's 56, their deviation would be 56 minus 66, so they have a deviation of negative 10. 62. 62 minus 66 is negative 4. So that person has a deviation of negative 4. This person's average, so their deviation is just 0. No deviation. 72 minus 66 has a deviation of positive 6. So deviation is just distance from the mean. Now what I want to do is with all of these deviations, I want to average them. Average the deviations. I want to know, on average, how far is everybody from the middle? But there's a slight problem with this. So check this out when I actually do it in the spreadsheet. And I'm going to make another column for this. So I'll mess this up. So over here, I'm going to make a column called deviation. And I need to know the average, so I'm going to put the average in here too. So you don't need to repeat this here, just watch what I do. So the average is just average data. So I'm going to use that number right there. So to calculate the deviation for somebody, I just take whatever their height is and I subtract the average. Now, when I copy this down, I always want to pick a new height of a person, but the average is always located here. So I don't know if you remember the trick from before. To fix that, we put a little $sign in front of the 2 there, which says when you copy this formula down, don't mess with row 2 for this number. So my formula here is the height of the person, and the average is always in that spot. And then I can just fill that down all the way to the bottom. And this will calculate how far every one of these numbers is from average. So I have all these different numbers. If somebody is about 66, so here's a 66 and a 67. Notice those are pretty close to 0, about a ½ an inch below average here, about a ½ an inch above average. So column B are my deviations. Now, if I try to average stuff, right, you have to add them up. So if I wanted to add up all of those deviations, check this out. They add up to 0. So trying to average the deviations directly doesn't work. And the way to think about that is what average means. So I'm just going to talk about average and come back to standard deviation. Remember, it's the sum of the numbers, right? Add them all up, divide by how many there were. So let's take the following numbers. How about 3, 4, 5, 6, and 7? And suppose some friends get together, and this is how much money they have to work with. One person has $3, another has 4, another has 5, another has 6, another has 7. Looking at this list, 5 is right in the middle. The numbers are equally spaced, so 5 is going to be the mean. It's also the median, coincidentally, because the data is symmetric, perfectly symmetric. So that's the average there. If I were to add these numbers up and try to find, calculate that average more carefully than just looking, let's see, 3 and 7 is 10, 4 and 6 is another 10. So altogether that's 25. And there are 5 numbers. 25 divided by 5 is 5, right? So just double check, the average is 5. So when we add them up, we're kind of like pooling all their money together. Like say they're going out to dinner and they say, okay, this is how much money we have all together. We have 25 bucks, what can we get? That's the same thing as having, if everybody had $5, right? So same sum, 25, right? That's my sum. But the numbers could be distributed differently. If I distribute the same amount to each person, then each person is average. And there is no deviation. So the thing about average, it is the number that you could then redistribute to everything in all the people in your list so that they all have exactly the same amount and the sum is the same as what you started with. So because that's the essence of average, when you try to add up those deviations, you're always going to get 0. So the trick with standard deviation is what we do is we take those deviations, and part of the problem we're getting 0 is some are below average and some are above average. And so to get rid of those positives and negatives, we square those deviations. So now everything's positive. Then we add those up. So then we sum those up. And then we divide. And it turns out there's another bizarre trick that I really can't explain right now. Usually when we average stuff, we want to divide by how many? N. But it turns out whenever you're working with a sample, standard deviation, instead of dividing by n, you're supposed to divide by n minus 1. And there's a lot of theory behind it, but the bottom line is it tells us more information about what's happening with the rest of the population if we divide by n minus 1 instead of n. Now, you're never going to have to do this crazy calculation. That is, find all the deviations, then square them, then add them up, and then divide by n minus 1. Oh, and I forgot the last step. Then to get rid of the square, you take the square root of everything once you're done. Instead, we're just going to go to a spreadsheet and say, hey, STDEV, S, and then give it your data. And it does all of that for us, right? So we don't have to worry about that. The point of me talking about this right now is deviation is distance from the mean. If we can find a way to average those distances without getting a 0, then that tells us how spread out the data is. So if the standard deviation is a big number, the data is really spread out. If the standard deviation is a small number, the data is not very spread out. So it gives us a measure of how spread out the data is. So again, standard deviation is what we're calculating here. And it is a measure, the most popular one, of the average spread of the data. Deviation is an important number. That's for an individual. So a deviation is a calculation for a specific individual. Like for me, my deviation, if the mean was 66, was 2. Standard deviation takes all of the data and says, on average, this is how spread out the data is. Now, if we look back at our data for the heights of people, so playing with this chart right here, I have a standard deviation of about 4. So I'm just going to round it and say it's about 4. And again, it's distance from the mean, right? We can't forget that about standard deviation. Let's see if I put that in here. Standard deviation, a measure of the average spread. I missed that right here. Switch colors, sneak that in, from the mean. Right, the first step the computer does in calculating standard deviation is finds all of the deviations for every single number in the list. It asks every number, how far are you from the middle? How far are you from the middle? Squares them, adds them up, divides by n minus 1, and then takes the square root. So standard deviation, a measure of the average spread from the mean of the data values. And we think it's about 4 for this data set. So on the number line here, I'm just going to add a little bit more information. So let's use an easier number, like say it's 66. Then if I go 4 to the right, that would be 70. And if I go 4 to the right again, that's 74. 4 to the right again would be 78, roughly. Starting at 66, right? So I'm just kind of approximating using those two numbers. If I go 4 to the left, that puts me at about 62. 4 to the left again puts me at 58. And 4 to the left again puts me at 54. So this right here is my mean in the middle. So I'm using the mean. Mean goes with standard deviation, right? Average distance from the mean. And then I'm counting standard deviations across here. So this right here would be 1 standard deviation to the right. This would be 2 standard deviations to the right. This would be 3 standard deviations to the right. Going the other way, I would put a -1 to say 1 standard deviation to the left, a -1 for 2 standard deviations to the left, and a -3 for 3 standard deviations to the left. So my height is about 68. So that's right in between 0 and 1 standard deviations to the right. So I'm like half a standard deviation above average. If somebody was 70 inches, they're about 1 standard deviation above average. 74 is about 2 standard deviations above average. When on most data sets, what we're going to find is that if we look 2 standard deviations to the right and 2 standard deviations to the left here, that we're going to find about 95% of the data is within 2 standard deviations of the mean. And you really can't talk about the standard deviation without also talking about the mean. It makes no sense because the standard deviation is based on the mean, not the median, the mean, right? Notice I grouped these two together in my table, the mean along with the standard deviation. So we'll play with this number some more today for other data sets. We're going to play with it more next class, and it's kind of just something you got to get used to if you've never seen it before. So when I want to talk about a data set, right, I have the graph to talk about it. So I can show someone this graph. I can say on average, people are about 66, students are about 66 inches tall. That's one thing I can make for a claim here. On average, the spread is about 4 inches from 66. That's another claim I can make about this data so far. The shortest person was 52, the tallest was 58. That gives us a range of 26 inches. So these are all ways to summarize the data. So we'll come back to percentiles in a little bit. I just want to pick another data set and play around with the first few basic statistics here. So let's get a new data set.